Yes, this is Dr. Obasi Nathaniel. I will be welcoming you to another fantastic session of instructional video on soil morphology. And we'll be considering subtopics such as micromorphology, look at porosity, and look at soil texture. I encourage you to do your part to be a part of this class as you really enjoy yourself with us. So once again, I welcome you. Thank you. Yes. The topic of today's instructional video is soil morphology. I remain Dr. Obasi Nathaniel, and my introduction will be looking at, first of all, soil morphology. We say that soil morphology is a field of observable attributes of the soil within the various soil horizons and the description of the kind and arrangement of this horizon. In 2003, Mabot championed reliance on soil morphology instead of on theories of pedogenesis for soil classification, because theories of soil genesis are both ephemeral and dynamic. The observable attributes ordinarily described in the field include the composition, form, soil structure, and organization of the soil, color of the base soil, and features such as mottling, distribution of roots and pores, evidence of translocated materials such as carbonate, iron, manganese, carbon, and clay, as well as the consistency of the soil. The observations are typically performed on a soil profile, and a profile is a vertical cut or two-dimensional in the soil and bound on one side of a head-on. Now, the objective of today's class is, at the end of this class or unit, you should be able to know the meaning of micromorphology, porosity, as well as soil texture. Now, micromorphology, why soil micromorphology begins in the field with routine and careful use of about 10 hand lengths. Much more can be described by careful description of thin section made of the soil with the aid of a petrographic polarizing light microscope. The soil can be impregnated with an epoxy resin, but more commonly with a polyester resin, and sliced and ground to 0.03 millimeter thickness and examined by passing light through the thin soil plasma. Now, porosity of soil typically described a grain size increase. This is due to soil aggregate formation in finer texture surface soil when subject to soil biological processes. Aggregation involves particulate adhesion and higher resistance to compaction. So typical bulk density of soil or sandy soil is between 1.5 to 1.7 gram per cm cube, which is to say that sand has very high bulk density. Sand has very high bulk density compared to clay, and this calculates to porosity between 0.43 and 0.35. So the typical bulk density of clay soil is between 1.1 to 1.3 gram per cm cube. So this calculates to porosity between 0.58 and 0.51. So this seems counterintuitive because clay soils are termed heavy, implying lower porosity. Heavy apparently refers to a gravitational moisture content effect in combination with terminology that harken back to the relative force required to pull a tillage implement through the clay soil at field moisture content as compared to sand. Now, soil texture, an experienced soil scientist can determine soil texture in the field with decent accuracy, but not all soils lend themselves to accurate field determination of soil texture. The mineral texture can be obfuscated by high soil organic matter, iron oxide, amorphous, or short-range order aluminosilicate and carbonate. Soil texture is the relative relations of the component sand, silt, and clay, most often reported as percentages on a mass basis. Cultivation disturbs the soil, causing fragmentation, compaction, as well as displacement. Now, activities, you are to discuss the morphological characteristics of soil, write short notes on soil micromorphology, soil porosity, as well as soil texture. By conclusion, soil morphology is composed of composition, forms, and soil structure, as well as organization of the soil, color of the base soil, and features such as mottling, distribution of roots and pores, evidence of translocated materials such as carbonate, iron, manganese, carbon, and clay, as well as the soil consistency. Thanks.